Hello everyone and welcome to our video lesson on 1-4 angle measure. We have some more terms today. Before we can define what an angle is, we first have to define what a ray is. A ray is part of a line with one endpoint. So you know how lines, they went on forever? There was an arrow on one side and there was an arrow on another side. That's a line. Lines go on forever. Now a line segment is part of a line with two endpoints. So we call it like A and B. That was segment AB. Now a ray is kind of a mixture of a line and a line segment. It has one endpoint, but the other part of the line goes on forever. There are different ways to name a ray. Just like there's several ways to name a line, you have to use two letters, but this time you must start with the endpoint. That is a must. Whereas in lines and line segments, they could have went in either order. So this one, I have to start with point A because that's the end point. And then I could name any other point on the ray. So AB, and then I put an arrow over it where I start again with the end point. So there's the end point AB. I could also call this ray AC. As long as you start with the end point A, you could name any other point on the ray. So for the second one, here's X, Y, Z. I would start with point X because that is the endpoint, and then I could use Y or Z. So X, Y with an arrow over it. That's how you name a ray. Opposite rays are rays with a common endpoint extending in opposite directions. So they both have this common endpoint B, and so BA goes in one direction, and then its opposite ray, BC, goes in the other direction. So together they make a line. They are called opposite rays. Now they must have the same endpoint. It says right here they have a common endpoint. So this phrase right here, BA and AB, are not opposite rays because they don't have the same endpoint. Okay. Now we can define what an angle is. It's kind of a long mathy definition. It's two non-collinear rays that have a common endpoint. So here's a picture of an angle. What I want you guys to do in your notes is I want you to write down all these other words in here. This is called the interior of the angle. So please write that on the inside of the angle or on the interior. So then everything on the outside of the angle is called the exterior. Now two rays make an angle. So one ray is the side CB. And as you can see, there's an arrow over at CB. You start with the endpoint C and then it goes out to B. The other side is side CA. Now, a very important thing in a angle is the vertex. The vertex is that endpoint where both rays come together. So C is the vertex. There's different ways to name an angle. You usually name an angle using three letters. The vertex is always in the middle. So we could call this angle ACB. That's one way to name the angle. Again, the vertex always has to be in the middle, so you could call it angle BCA. And I should say this too. This kind of cursive looking L type thing, that's a symbol that means the word angle. So ACB or angle BCA. Another way that you could label an angle is just by its vertex. We could call this angle C. But most times we use three letters as we go around the angle. So angle A, C, B, or in the other way, angle B, C, A. Those are different ways to label the angle. And it says here that there's 4 different ways. Sometimes what some books or worksheets will do is they'll put, like at the vertex, they'll put a number there. Like if they put angle 3, that's another way of labeling this angle. ACB is the same way of saying angle 3. So you kind of need to know all 4 of those ways because they're used synonymously at times. All right, angle classification. There are acute angles, right angles, obtuse angles, and straight angles. Acute angles are less than 90 degrees, but they're greater than 0 degrees. So here's what this means. The measure, this lowercase m right here, means the measure of angle A is greater than 0, but it's less than 90. Right angles are exactly 90 degrees. So oftentimes they are noted with a box in the corner. that means that that angle is exactly 90 degrees. Horizontal lines and vertical lines, when they meet, it's exactly 90 degrees. Another word that we use for that is perpendicular. So 90 degrees. Obtuse is where it's greater than 90 but less than 180. So the measure of my angle, the measure of angle C, is bigger than 90 degrees but it's less than 180. And then a straight angle, that's kind of where our opposite rays come into play. A straight angle is exactly 180 degrees. So 4 ways to classify an angle: acute, less than 90; right angle, exactly 90; obtuse, greater than 90 but less than 180; straight angle, less than 180. Or sorry, straight angle, exactly 180. Congruent angles, just like congruent segments were two segments that were the same length, congruent angles are angles that have the same measure, or angles with equal measure. So this is kind of one of those things where if this is 40 degrees and angle M is congruent to angle N, then this one is also 40 degrees. Or if this angle M were to be 5x minus 17 and this angle were to be 3x plus 11, now we could set the two angles equal to each other because they are congruent. So if we were to solve, we would set 5x minus 17 equal to 3x plus 11. Just an example of a type of problem that you might see in an assignment. So when angles are congruent, they have the exact same measure. All right, so looking at this one, each point of Kermit the Frog star on the Hollywood Walk of Fame is a congruent angle. Find the measure of each angle of Kermit's star. So if each point is a congruent angle, how is that worded again? Each point of Kermit the Frog star is a congruent angle. So there's 5 points to a star, or 5 angles, 1, 2, 3, 4, 5, and they're all congruent to each other. So that means if one angle is 12, they're all 12. If one angle is 17 degrees, they're all 17 degrees. If one angle is 2x plus 5, and another angle is 3x minus 10, they're all the same measure, so that means they have to be equal to each other. 2x plus 5 equals 3x minus 10. Now we can solve for x. So as we solve for x, I might subtract 2 x's from both sides, and I will add 10 to both sides. So I get 15 equals x. So x equals 15. What you're going to find out in geometry is once you solve for x, that's oftentimes not the answer. This says find the measure of each angle of Kermit the Frog star. So 2 times x, or 2 times 15 plus 5, is the measure of this angle. And 2 times 15 is 30. And 30 plus 5 is 35. This angle right here is 3 times 15 minus 10. 3 times 15 is 45, and 45 minus 10. What do you know? Would you look at that? 35 and 35. Is that coincidence? No, it should happen that way because the angles are congruent. So bottom line, if one angle is 35, they're all 35. That angle is 35 degrees. That angle is 35 degrees. This angle is 35 degrees. This one's 35 degrees, and this one's 35 degrees. Find the measure of each angle of Kermit the Frog star. They're all 35 degrees. We talked about what a segment bisector was. Remember, sect means the word cut. So when you dissect something, you cut something. Bisect, bi, means two. So an angle bisector is cutting an angle into two congruent parts. A ray that divides an angle into two congruent angles. So a segment bisector cuts a segment in half. An angle bisector cuts an angle in half. So this is where if the whole angle, this looks clearly obtuse, if it's a whole angle is 150 degrees, that means an angle bisector would cut it into 75 degrees and 75 degrees. It cuts it exactly in half. The two angles that it makes are congruent to each other. And that's what a bisector does. So now we can use that to solve more problems, such as this one. BD is a bisector. BD, this ray right here, ray BD, bisects angle ABC. So here's angle ABC. Notice B is the vertex that's in the middle. Find the measure. So this M right here, all of these mean the measure of. Find the measure of angle ABD. So this is my variable. That's what I want to find. Let's write down what we know. If the measure of CBD, so C to B to D, this green angle that I just drew, is 12A minus 8. 12A minus 8. And the measure of ABC, so the whole angle, ABC, this big angle right here, all of that is 22A minus 11. 22A minus 11. So what you need to know on this one is because BD is a bisector, because that one is a bisector, it makes two congruent angles. CBD is congruent to DBA. So if CBD is 12A minus 8, then ABD is also 12A minus 8. The two angles are congruent. And now, these two congruent angles, when you add them up, it equals the whole angle. It's kind of like the segment addition postulate, where one segment plus another segment equals the whole segment. Here's the angle addition postulate. One angle plus the other angle equals the total angle. So, 12A minus 8 plus the other part of the angle, which is also 12A minus 8, that equals the total angle of 22A minus 11. The two parts add up to make the whole. All right, solving. We have 12A and another 12A. That makes 24A. We have a negative 8 and a negative 8, and that makes a negative 16. Equals 22A minus 11. I'm going to add 16 to get it onto the right side, and subtract 22A to get it onto the left side. All right, so now we have 24A minus 22A is 2A, and a negative 11 plus 16 equals a positive 5. So when we divide both sides by 2, A is equal to 5 halves, or 2.5, or 2.5, either one. So that is the value of A. Let's see if we've answered our question. Our question says, find the measure of ABD. So angle ABD. ABD is this 12A minus 8. That is what our answer is. 12A minus 8. So the measure of angle ABD is 12 times A minus 8. Did I get that right? 12 times A minus 8. And A is 5 halves. So 12 times 2.5, 12 times 2.5 is 30. And 30 minus 8, that would be 22 degrees. Angle ABD is 22 degrees. If you want to check your work, you could put 5 halves into there, and you should get 44 degrees. Because if one angle is 22, it's bisected, so that means the other angle is 22, and 22 plus 22 make the whole angle 44. You could put that right in there, and I bet you'd get 44 degrees. There is lesson 1-4. Be sure to let me know if you have any questions when you get to class tomorrow.